This is Unit 7, Video 4 on Molarity Stoichiometry. So now we're going to take molarity, since we understand molarity, and we know molarity times volume equals moles, and do some stoichiometry with it. That's really what moles is all about. It's giving us the number of particles present. So we learned when we did stoichiometry that we could take grams of A to moles of A to moles of B to grams of B. And we could go anywhere in here. We might start here and end here, start here and end there. We can do any combination. Doesn't mean every problem has to go all the way. But now we can take the molarity of A times the volume of A and go straight into moles of A. We don't even need the molar mass of A to do this. Or we could come out and get molarity here at the end, either one. So if I have the molarity times the volume, that gives me the moles. I skip the periodic table conversion, grams to moles. And now I can do my progression. If I'm looking for a theoretical yield, I'll probably get the grams. If I'm looking for something else, then whatever it's telling me to do. So let's work through that. All right? We've got a balanced reaction here. Silver nitrate mixed with calcium chloride will produce solid silver chloride and calcium nitrate in solution. It's balanced. We see we have a 2-to-1 ratio between silver nitrate and calcium chloride, and then there's a 2 on the silver chloride. So we're going to go to the theoretical yield of the silver chloride. That's our product that's produced. It's a solid. We can separate it out. If 20 milliliters of a 3 molar calcium chloride solution, so we've got volume and molarity of the calcium chloride, is added to a concentrated silver nitrate solution. Silver nitrate is concentrated. We're going to have plenty of it. We're not concerned with the silver nitrate. What we're concerned with is the moles of calcium chloride. We know molarity times volume equals moles. So let's go ahead and do the calculation here. So molarity of the calcium chloride times the volume of the calcium chloride equals moles. Well, that's going to be 3 molar times 0.02 liters. Okay, that's going to give me 0.06 moles. So that's my moles of calcium chloride. Now I want to find silver chloride. That's my goal. Well, first step, since I have moles of one substance going to moles of a different substance, that's going to be my mole ratio. That's my stoichiometry step. I'm going to put calcium chloride on the bottom. I'm going to put silver chloride on top. This is a 2. This is a 1. So now I have the total moles of silver chloride. I could write it down. It would be 0.12. But I'm going to go ahead and just finish off. Since I want the theoretical yield, I want the molar mass, 142.87 grams per mole of silver chloride. Punch into my calculator. And I will have the mass of silver chloride produced, at least the theoretical yield of the mass, which is 17.1 grams. So 17.1 grams of silver chloride would be produced in this reaction as long as we have a concentrated silver nitrate solution.